find cos cubed theta in terms of first powers of the cosine function. So we don't want any cos squareds or cos cubed in there, but we might have some 2 theta or a 3 theta, something like that. Only raised to power 1. Okay, there's a very useful result that can help us do this. Okay, so if we consider some kind of complex number, and we're going to make sure it has a modulus of 1, we'll do that soon. So some z to the n plus the reciprocal of z to the n, which is the same as 1 over z to the n. So some complex number z, which we're going to define as having a modulus of 1. We're just going to see if we can get a result for this that we can use. So if you say let z equal cis theta, and I'm not saying cis theta because I said that the modulus was 1, so it's 1 cis theta. So z to the n would be cis n theta, so that would be cos n theta plus I sine n theta. Okay, the reciprocal of that, so 1 over z to the n. If you recall, if you're finding the reciprocal of a complex number, you take the reciprocal of the modulus. The modulus is just 1, so the reciprocal of 1 is still 1, and then you times the argument by -1, so it would be cis minus n theta, like that. I could put a bracket around there as well. Okay, so that would be cos minus n theta plus I sine minus n theta. And you need to remember a little bit about cos minus theta and sine minus theta. So if we just draw a little unit circle, so if we take some theta here, so that can be theta. So this has coordinates of cos theta, sine theta, like that. And if we draw minus theta, so it's the same angle but it's negative, so that there is, I can't put it in, minus theta, like that. This has coordinates, but it's still cos theta because the x coordinate is still positive, but it is minus sine theta. So this diagram is a very quick way of demonstrating that cos minus theta equals cos theta, and sine minus theta equals minus sine theta. So cos theta is an even function because cos minus theta equals cos theta. And sine theta is an odd function because sine minus theta equals minus sine theta. Okay, so if we put all of this together, z to the n plus 1 over z to the n, well, that's going to equal cos n theta plus I sine n theta, cos n theta plus I sine n theta, plus cos minus n theta plus I sine minus n theta, plus I sine minus n theta. Okay, so now we can use the identities that we've just demonstrated, as in cos minus n theta is cos n theta, and sine minus n theta is minus sine n theta. So z to the n plus the reciprocal of z to the n equals cos n theta plus I sine n theta plus another cos n theta minus an I sine n theta. Okay, so if you look at the I sine n thetas, they disappear, they cancel out, and if you look at the cos n thetas, we're going to have 2 of them. So a really important result. Remember, we're only considering complex numbers with a modulus of 1, z to the n plus the reciprocal of z to the n equals 2 cos n theta. Okay, so this is the result we're going to use to actually do the question. So find cos cubed theta in terms of first powers of the cosine function, right? So basically, if we take n as being 1, we can say z plus 1 over z. Well, that must equal, but n is 1, so it must equal 2 cos theta. Okay, so we are looking now to use this to get an expression for cos cubed theta. So if we cubed both sides, then we're going to have a cos cubed theta, not just cos cubed theta, but it's a good start. So z plus 1 over z cubed is going to be 2 cos theta cubed. Okay, to do the z plus 1 over z cubed, we're going to have to use a binomial expansion. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So that is going to be z cubed plus 3 z squared 1 over z plus 3 z to the power 1 and 1 over z squared, plus then you've got 1 again, it's just 1 over z cubed. So that must equal 8 cos cubed theta. Okay, so if we now try and simplify this left hand side as much as we possibly can, so you've got z cubed plus 1 over z cubed. I'm going to put those together, so the first bit and the last bit, I'm going to put those together for reasons that will become clear very soon. So z cubed plus, and the 1 over z all cubed, well, it's 1 cubed over z cubed, which can be written as 1 over z cubed, plus, and then this second term, you've got 3 times, it's just z, so it's 3z, 3z, and then here you've also got a 3. Now I'm actually going to pull the 3 out because I've got 3 as a common factor, both of those. So you've got z as from this term, and then here you've got z over z squared, so that's times 1 over z, so plus 1 over z, that's the left hand side, equals 8 cos cubed theta. Okay, so now we can go back to our identity that we're going to use again. So you've got z to the n plus 1 over z to the n. So here we've got z cubed plus 1 over z cubed equals 2 cos n theta. So all of this, or these first two terms, can be written as 2 cos 3 theta. 2 cos 3 theta plus 3 times, and we already know that z plus 1 over z is 2 cos theta. 3 times 2 cos theta, well, that equals 8 cos cubed theta. And we're now very close to be able to have an expression for cos cubed theta. We just need to divide it through by 8 and tidy up a little bit. So cos cubed theta on the right hand side, once we divide through by 8, equals 2 cos 3 theta over 8. Well, 2 over 8 is 1 over 4, so we'll call that 1/4 cos 3 theta plus, well, you've got 3 times 2 is 6. 6 over 8 is the same as 3 over 4, so that plus 3 over 4 cos theta. Okay, now it's up to you how you present it, but some people might like to pull a quarter out. It could be argued that it looks slightly nicer, but what definitely would look nicer is if the cos cubed theta was on the left hand side. So to finish off, cos cubed theta, and like I say, I don't really think it matters if you pull the quarter out or not, but I will do it. So that equals 1/4. So if we pull a quarter out of that, we're just going to have cos 3 theta. And if we pull a quarter out of 3/4, we're going to have plus 3 cos theta. Okay, so this is a very useful and very common application of De Moivre's theorem. And I have seen quite a lot of exam questions that that sort of build up like this, and you have to do similar things. So it's a very useful thing to practice.